Top 10 gemstones that everyone thought were rare until the truth came out. What makes a gemstone rare? For some, it's the color, saturated, pure, and hard to replicate. For others, it's the location, a single mine, a single moment in geological time. And sometimes it's neither. Across decades, dealers, collectors, and even gemologists have placed value on stones they believed were exceptional, based on appearances, market trends, or stories that were never thoroughly checked. But behind those stories were processes, treatments, misclassifications, and trade habits that reshaped how these gems were seen and sold. In this documentary, we examine 10 gemstones once considered rare, each of them admired, displayed, and even hoarded, until closer analysis revealed a different perspective. Not with scandal, with data. Because in gemology, the question isn't just what a stone looks like. It's how well we understand what it truly is. Don't forget to press and hold that like button, leave a comment, and hit subscribe before we begin. Ranked 10th, blue amber. Blue amber was once pursued as a singular phenomenon within the world of fossilized resins. Its reputation wasn't built on age alone, though many samples are 20 to 30 million years old, but on something visual, a vivid blue glow when exposed to UV light or direct sunlight. This luminescence, rarely seen in traditional amber, sparked market excitement throughout the early 2000s. In Dominican gem fairs, even small specimens that glowed blue could fetch prices 10 to 15 times higher than standard yellow amber. Traders marketed them as unearthed from a single deposit, prehistoric light sealed in resin, or even energy-rich relics of ancient atmospheres. When similar pieces began surfacing from West Sumatra, Indonesia, the glow was enough to carry over the myth. Blue amber was rare, unique, and valuable. The scientists began asking questions. Over the next decade, laboratories including the Gemological Institute of America, GIA, Gem Research Swiss Lab, GRS, and the University of Hamburg began analyzing samples using Raman spectroscopy, UV vis absorption, and fluorescence profiling. The findings were consistent. There was no intrinsic blue pigment, no structural anomaly, and no trace element responsible for the color. Instead, the luminescence came from polycyclic aromatic hydrocarbons, PAHs, a class of organic molecules that absorb ultraviolet light and re-emit it in the blue spectrum. These compounds form naturally in many fossil resins under specific burial and temperature conditions, and they're not exclusive to the Caribbean or Indonesia. When researchers tested amber from Mexico, Myanmar, and even the Baltic region, the same blue glow emerged under UV light. The implication was clear. Blue amber isn't a separate species, nor is it geologically rare. It's a known optical response, previously overlooked, now misunderstood. By 2005, gemological authorities began issuing warnings against classifying blue amber as a standalone gem type. Institutes like SSEF and GIA clarified that optical effects, however striking, do not constitute rarity unless supported by structural, mineralogical, or locality-based constraints. Still, commercial markets, especially in metaphysical and tourist sectors, continued to present blue amber as an elite material, often using outdated or unverifiable claims. Today, blue amber remains available, but under new terms. On most regulated platforms, it's now described more accurately as natural amber exhibiting blue fluorescence. The market price reflects this correction. Once promoted collections, previously labeled as one of a kind, have been re-evaluated and grouped with standard fossil resins. Under normal lighting, many of these pieces appear no different from their yellow or honey-colored counterparts. The blue glow is still there. However, the idea that it makes the stone rare no longer holds up under scrutiny, not because the amber changed, but because the facts finally caught up. Ranked 9th, mystic topaz. Some stones didn't rise from the earth. They were engineered, precisely, thinly, deliberately, to reflect what we wanted to believe. There's something immediate about mystic topaz. Its surface flashes in violet, green, crimson, and blue, sometimes all at once. At first glance, it doesn't resemble any known gem species. The color appears layered, almost holographic. Its name, mystic, only amplified the intrigue. In the early 2000s, this gemstone was featured in catalogs and on retail counters. Shoppers were told it was a rare type of topaz, treated with a secret process found only in select mines. Prices soared. In some cases, mystic topaz sold for more than imperial topaz, despite lacking any geological pedigree. However, behind the spectacle lay a carefully controlled process. Mystic topaz begins as colorless topaz, often from Brazil or Sri Lanka, chosen for its clarity and durability. That topaz is then coated with an ultra-thin film of titanium or bismuth, applied via chemical vapor deposition, CVD. The interference between light and the metal layer produces the gemstone's signature rainbow effect. The stone hasn't changed inside, only the surface reflects a new identity. There's no mystery, no optical anomaly, just precision coating on a non-rare mineral. The illusion held until gemological institutions began requiring full disclosure. By 2005, organizations such as the GIA and AGTA had made it clear. Mystic topaz is not a natural color variety. It is a treated gemstone, and any commercial sale must clearly state this. In markets where disclosure was enforced, prices fell rapidly. Today, mystic topaz is no longer positioned as rare. It's sold as a fashion gem, bright, inexpensive, and available in bulk. Jewelers now group it with lab-created quartz, coated druzy, and other decorative stones. Under magnification, the coating is often uneven or scratched. Its resale value is negligible. The visual effect still draws attention. But the moment of confusion has passed. This was never a rare gemstone, just a well-executed surface, marketed before the questions arrived. Ranked 8th, Prasiolite, a rare gem, until we looked closer. For a time, green quartz was considered one of the rarest members of its mineral family. Jewelry catalogs described it as a natural phenomenon, a green-hued variety of amethyst found only in select deposits. The color, soft, almost transparent mint, felt distinct enough to support that claim. It was marketed under names like green amethyst and verdolite quartz, sold at a premium, and displayed in high-end boutique settings. But almost everything about that narrative was inaccurate. The quartz wasn't green to begin with, it was purple. Nearly all green quartz sold commercially is the result of deliberate transformation. Known as prasiolite, the stone is produced by heat-treating or irradiating amethyst, most commonly from Brazil or Bolivia. When subjected to temperatures near 500 degrees Celsius or to controlled gamma radiation, the deep violet of amethyst fades and shifts into a green hue. To the eye, the change seems natural. Structurally, the material remains unchanged. It is still quartz, just altered in color through artificial means. Gemological authorities initially hesitated to intervene, but by the early 2000s, institutions such as the Gemological Institute of America, GIA, and the World Jewelry Confederation, CIBJO, issued formal clarifications. First, the term green amethyst was declared inaccurate and prohibited in professional documentation. Second, it was confirmed that truly natural prasiolite, formed geologically, not in furnaces, is exceptionally rare, found in only a handful of localities such as Poland and Quebec. Third, sellers were required to disclose when green quartz had been treated, something few had done prior. As disclosure became standard, the perceived value of prasiolite declined. No longer considered a rare geological event, it was reclassified as a commercial product, treated quartz with limited investment or collection value. In the metaphysical market, it continues to circulate under symbolic interpretations. But in the regulated gem trade, its classification is now precise. The stone itself has not changed, but our understanding of it has. What once looked rare from the outside is now understood, layer by layer, for what it truly is. Ranked 7th, Aura Quartz. Color that was never in the stone. The surface of Aura Quartz delivers an impression that few gemstones can match. It radiates in waves of electric blue, violet shimmer, and iridescent green, sometimes all within a single glance. To many, it appears otherworldly, almost synthetic in its beauty. And that's precisely what it is. Despite being sold under names like Angel Aura, Titanium Quartz, or Aqua Aura, The stone at its core is neither rare nor mysterious. It is natural quartz, chemically and structurally identical to the same silicon dioxide found in vast deposits across the globe. What makes it different is not what's inside, but what's been added to it. Through a process known as vacuum vapor deposition, a thin layer of metal, often titanium, gold, niobium, or platinum, is bonded to the quartz surface under high heat and low pressure. The layer is nanoscopic, measuring less than half a micrometer thick, yet it refracts light in complex ways. The result is a shimmering, rainbow-like coating that mimics the appearance of something far rarer than it is. This treatment does not alter the internal crystal structure. It does not create a new mineral, and it does not occur in nature. The coating, though beautiful, is purely cosmetic. It is also fragile. Over time, it can wear off through simple contact with skin, air, moisture, or household chemicals. Once the surface begins to degrade, what's left is untreated quartz, transparent, durable, and abundant, but commercially modest in value. For a time, none of this stopped the excitement. During the late 1990s and early 2000s, titanium-coated quartz was widely marketed across spiritual and alternative wellness communities as a powerful energy tool, often described as a bridge between the physical and metaphysical. Sellers claimed it carried frequencies tied to higher consciousness, angelic realms, or planetary vibrations. In reality, it had a vaporized trace of industrial metal on quartz from Arkansas or Brazil. Gemological institutions have never categorized aura quartz as a legitimate gemstone class. The Gemological Institute of America, GIA, along with AGTA and CIBJO, consistently list it as a treated material, not as a mineralogical variety. There are no known geological conditions on Earth that naturally produce quartz with these colors. The treatment is entirely human-made, reproducible at scale, and customizable by metal type and coating thickness. Once gem buyers and collectors understood this, the valuation adjusted accordingly. Aura quartz transitioned from high-end display cases to fashion jewelry and metaphysical retail. Its price per carat dropped, its classification was clarified, and its status as a so-called rare gemstone quietly disappeared. Today, it remains popular among decorative and metaphysical communities, but its role in the professional gem trade is effectively non-existent. It's not featured in mineralogical surveys, it's not sought after in auctions, and it's not accepted in fine gem investment portfolios. The brilliance it offers remains, but the belief that it ever came from nature, that part has faded. Ranked 6th, red andesine, the color that came from nowhere. At the start of the 21st century, a new red gemstone entered the global market with unexpected force. It shimmered with metallic flashes. It carried a crimson to orange hue rarely seen in feldspar, and it came with a label that added mystique. Tibetan Andesine. Sellers described it as a natural plagioclase feldspar found in remote high-altitude deposits. Its color was said to be inherent, untouched, and unique to one location. Demand skyrocketed. Jewelry networks promoted it as a rare alternative to ruby. Gem collectors were drawn to the Schiller-like sparkle, which resembled Oregon sunstone, but with deeper saturation. Within a few years, red andesine had appeared in catalogs, boutique displays, and metaphysical collections, commanding prices far exceeding those of other feldspars. Few questioned the narrative. Fewer still asked to see the mines. The story began to unravel in 2008. Independent gemologists, unable to verify the original mine localities, submitted large quantities of red andesine for advanced testing. Spectroscopy and chemical mapping revealed something troubling. The presence of diffused copper ions, patterned inconsistently and penetrating only surface zones of the crystal. Natural feldspar, when red, contains copper distributed evenly through growth. These samples did not, they had been altered. Further investigations showed that much of the material had originated as gray labradorite from known deposits in China and Mexico. The color had been artificially introduced through high-temperature copper diffusion, a technique previously undocumented in feldspar, but known in the treatment of sapphire. Field expeditions to the claimed Tibetan and Mongolian mines either found no gem-grade deposits or no operations at all. The trade responded slowly. Many vendors had bought large quantities of the stone in good faith. Some insisted the treatment was partial or disputed the findings outright. However, by 2010, institutions such as the GIA, SSEF, and GRS had issued official warnings. Red andesine must be presumed to have been treated unless otherwise proven. The central gem shows quietly removed the stone from the exhibition. Retailers reclassified it as ornamental feldspar. Today, red andesine is no longer considered a natural gemstone by most gemological standards. The market that once called it rare now treats it as a cautionary tale. Its color still shines, but its value and its origin story do not. Ranked 5th, blue topaz, the gem that became too common to stay rare. For centuries, topaz has been admired for its shades of gold, champagne, and pale yellow tones, which are found in natural deposits from Brazil, Russia, and Sri Lanka. Blue topaz, by contrast, was once so rare that it was considered a rarity. The color, whether sky, Swiss, or London blue, was rarely seen in nature. So when the gem market suddenly began offering large quantities of vivid blue topaz in the 1980s and 1990s, many assumed a discovery had been made. There was no discovery. There was a process. What appeared in the market as natural blue topaz was, in almost every case, a product of treatment. The process begins with colorless or pale topaz, which is mined in large volumes, primarily from Brazil, Nigeria, and Pakistan. These stones are then subjected to irradiation, often with neutrons, electrons, or gamma rays, to alter their internal crystal structure. The exposure transforms the color, which is then stabilized through heat treatment. The results are consistent: sky blue, Swiss blue, and the darker London blue, each determined by the dose and method of radiation. None of these stones is synthetic. They are natural topaz, but their color is not. And while the process does not involve dyes or coatings, it is entirely human-made and highly scalable. By the 1990s, treated blue topaz was available in such large quantities that it became the most widely sold colored gemstone in the world by volume. Jewelry retailers praised its affordability and brilliance. It appeared in rings, pendants, and commercial catalogs across North America, Europe, and Asia. Few buyers were told how the color had been created. Fewer still understood the implications. In gemology, rarity is not just about beauty, it's about the conditions required to produce that beauty. In nature, blue topaz forms under particular geological circumstances, and such stones are both rare and expensive. In treatment facilities, those conditions can be simulated in weeks and at scale. By the early 2000s, industry groups began enforcing more explicit disclosure rules. Institutions such as GIA and CIBJO require that treated blue topaz be labeled as such. In some jurisdictions, irradiated stones were subject to safety holding periods before sale. The effect was not a collapse in sales, but a collapse in perceived rarity. Today, blue topaz remains popular due to its vibrant color and exceptional clarity. But it is no longer viewed as rare. Its value is determined by cut, size, and transparency, not origin or scarcity. The market accepts it as a treated product, available in nearly unlimited supply. Its presence is legitimate, but its mystique is gone. What once surprised the gem world now saturates it. The stone didn't change. What changed was how often it could be made. Ranked 4th, color change garnet, when a natural illusion was taken for something else. The ability to change color under different lighting is one of the rarest optical effects in the gem world. When it happens, it draws immediate comparisons to one of the most famous gems in history, Alexandrite. So when garnets were discovered that could shift from greenish blue in daylight to reddish purple under incandescent light, the reaction was swift. Collectors, jewelers, and even some laboratories labeled them as extraordinary. A new frontier in garnet, and perhaps a rival to Alexandrite itself. That resemblance would become both the gem's advantage and its problem. Color change garnets are genuine. Their ability to alter hue stems from a complex absorption pattern across the visible spectrum, specifically due to the presence of vanadium, chromium, or a mixture of rare earth elements in their crystal structure. In certain lighting conditions, this can produce a visible shift that mimics the famed Alexandrite effect. The phenomenon is natural, and the stones are unenhanced. But unlike Alexandrite, whose formation conditions are exceptionally narrow and whose global supply remains critically low, garnet is geologically common. Even within the group of color change garnets, most of which are mixtures of pyrope, spessartine, and almandine, the availability is significantly broader. Deposits have been found in Sri Lanka, Madagascar, Tanzania, and even parts of the United States. The confusion began when commercial sellers leaned into the visual similarity and priced the stones accordingly. Some were even misrepresented, intentionally or not, as Alexandrite itself, especially in lower-end retail chains or unverified online markets. At the same time, some gemologists overstated the rarity of their findings, citing individual mines rather than broader ranges of deposits. The impression created was one of scarcity. However, as more material reached the trade and gemological testing became more routine, a pattern emerged. The phenomenon was authentic, but the assumption of rarity was not. Laboratories including GIA and SSEF began issuing clearer reports, distinguishing color change garnet as a natural but not geologically rare stone. Its color shift was notable, but not limited to one source, and not difficult to reproduce under the right mineral conditions. In time, the market adjusted. While high-quality color change garnets still command interest, they no longer carry the prestige or the price once associated with Alexandrite. Most are now priced according to size, intensity of the shift, and transparency, not mistaken identity. The garnet group remains one of the most varied in gemology. However, the idea that one of its members might replace Alexandrite has quietly faded. It wasn't the gem that lied. It was the comparison that went too far. Ranked third, lead-filled ruby, a stone that looked whole, but wasn't. For centuries, ruby has stood as one of the most revered gemstones in human history, symbolizing power, protection, and wealth. The most valued rubies from Myanmar's Mogok Valley or Vietnam's Luc Yen mines were prized for their deep, vivid red and high transparency. These stones were rare, durable, and nearly immune to confusion, until a new kind of ruby began entering the market. At first glance, it looked authentic. It displayed the correct color, reflected light like fire, and tested as corundum under standard gemological tests. In some cases, even experienced jewelers struggled to tell the difference. But under magnification, something was wrong. Fractures ran through the interior, filled not with healed crystal, but with something else entirely. The technique was called lead glass filling, and it changed how the world viewed ruby. The process began with extremely low-grade corundum material that would typically be rejected due to its extreme fracture density and opacity. These fragments were cleaned, heated, and infused with a high refractive index lead-based glass. Once cooled and polished, the result was visually dramatic, from chalky and useless to a gemstone that under casual inspection resembled high-quality ruby. Its color was improved, its clarity transformed, and its market readiness accelerated. But the material was fragile. While natural ruby rates 9 on the Mohs scale of hardness, the lead glass filler does not. It's vulnerable to heat, chemicals, and even simple ultrasonic cleaning. In effect, the stone's surface durability is that of corundum, but its internal structure is an engineered patchwork, part crystal, part glass. Between 2004 and 2007, large volumes of these treated rubies began entering the global market, primarily from Thailand and Madagascar. They were sold through traditional trade routes and, in many cases, without proper disclosure. The treatment was not new, but the scale was. Jewelers unknowingly sold them as natural rubies. Consumers paid natural ruby prices. Laboratories were forced to adapt. The turning point came in 2008, when multiple gem labs, including the GIA, SSEF, and Gubelin, issued joint statements warning that rubies filled with lead glass must not be considered equivalent to untreated or even traditionally heated stones. They called for mandatory disclosure. Some countries issued trade bans or import restrictions. Auction houses revised their listing policies. The gemstone industry began reclassifying the material entirely, not as ruby, but as a composite. Today, Lee glass-filled ruby is still sold, but only within clear boundaries. It is no longer allowed in fine jewelry catalogs without labeling. Its price per carat is a fraction of what untreated or even heat-treated ruby commands. In most professional gem databases, it's listed as treated ruby composite, not a standalone gemstone. The red remains. The shine still fools at first glance. But the structure underneath is no longer considered whole. Ranked second, Alexandrite. Outside Russia, a name that didn't mean the same. Alexandrite has long been regarded as one of the most enigmatic gemstones in the world. Its defining feature, a color change from green in daylight to red under incandescent light, is both visually striking and scientifically rare. Discovered in the Ural Mountains of Russia in the 1830s, the original stones were few, highly saturated, and formed under narrow geological conditions that included beryllium-rich pegmatites with traces of chromium. For nearly a century, no other location produced Alexandrite that matched their optical performance or mineral purity. That changed in the late 20th century, at least on paper. Starting in the 1980s, deposits in Brazil began producing chrysoberyl with a visible color change effect. By the 1990s, similar material emerged from Tanzania. These stones were sold as natural Alexandrite, complete with lab reports verifying their identity based on mineral species and observable color shift. Technically, they met the criteria. But over time, something became clear. They were no longer the same. The difference was both visual and structural. Russian Alexandrite exhibits a sharp, saturated change, from forest green to ruby red, due to a tightly balanced chromium to iron ratio. Brazilian and Tanzanian material, by contrast, often shifted from dull bluish green to a muted reddish brown, sometimes with overlapping tones. Chemically, these stones contain more iron, which dampens the color change. The result was a gem that was still chrysoberyl, capable of changing color, but less vivid, less rare, and often less valued. In the 2000s, as global supply increased, so did the confusion. Many retail buyers, unfamiliar with the nuances of origin-based quality, paid top prices for stones labeled Alexandrite without realizing they were purchasing material with low saturation. Online listings often featured gems with minimal shift, yet carried the same name. And while laboratory reports listed origin and spectral data, the distinction was lost outside expert circles. Gemological institutions responded with clarification. GIA, AGL, and SCCF all maintain that while origin does not change species, it does affect quality. Russian stones remained unmatched in market value. Brazilian and Tanzanian Alexandrites, while genuine, were reclassified by many collectors as commercial grade, real, but no longer rare in the same sense. The term Alexandrite had not become false, but its meaning had become broader and its mystique diluted. Today, origin is everything. Stones with sharp change, verified Russian provenance, and high saturation still command 5- to 6-figure prices. Others, despite bearing the same name, circulate at a fraction of that value. The color change remains, but the name no longer guarantees what it once did. Not all truths come from forgery. Some come from classification, and sometimes that's enough to change what a gem is worth. In first place, Herkimer Diamond, a perfect illusion until you measured it. In the world of gemstone trades, some misidentifications are accidental. Others are linguistic, but a few become traditions, widely repeated, never fully corrected, and profitable enough to persist. For decades, the term Herkimer Diamond has appeared on jewelry tags, tourist brochures, and storefronts across North America. The name evokes clarity, hardness, and rarity, qualities long associated with diamond. And the stone it refers to does, at first glance, offer all three. It is doubly terminated, it forms naturally in striking geometric shapes, and it sparkles with an almost unnatural brilliance when polished. But it is not a diamond, it is quartz. Specifically, it is rock crystal quartz, a colorless variety of silicon dioxide that forms inside dolostone cavities. The specimens found in Herkimer County, New York, are unusually well-formed, with natural faceting that mimics cut gemstones. Their luster, high transparency, and prismatic growth habit led to the nickname Herkimer Diamonds as early as the 19th century. The term gained traction not in gemological literature, but in tourism. Throughout the late 20th century, the Herkimer quartz industry became a regional phenomenon. Shops in upstate New York began offering jewelry, museum specimens, and metaphysical tools labeled as Herkimer Diamonds. Visitors could mine their own at public dig sites. The name was charming, the look convincing, and the geological story authentic. But in most transactions, one critical fact was missing. This material is chemically and structurally quartz. Its hardness is 7, not 10. Its refractive index is lower. Its market value is fractional. It does not meet any scientific or gemological definition of diamond. The confusion spread far beyond New York. Online marketplaces, metaphysical retailers, and even international sellers began using the term Herkimer diamond as a commercial designation. In some cases, the stones weren't even from Herkimer. They were simply well-formed quartz crystals from India, China, or Pakistan, sold under the same name. The effect was global, a common mineral dressed in a borrowed identity, priced above its classification. Gemological institutions have addressed the issue. GIA and CIBJO both classify Herkimer diamond as quartz and discourage the use of the term in formal documentation unless it is contextually clarified. It remains legal to use in trade, but only as a nickname, never as a species. Today, Herkimer quartz remains a collector's item, a teaching specimen, and a geological curiosity. But its role as a diamond substitute has faded under scrutiny. Reputable sellers now disclose their true identity. Its price reflects its abundance, and its value lies not in illusion, but in the precision of its formation. It was never a counterfeit, just a stone that looked right, until you measured it. Not every gemstone loses value when the truth comes out. Some simply find the right place in the spectrum. No longer misunderstood, no longer mispriced. What these 10 stones remind us is that rarity isn't declared. It's measured. By origin, by structure, by the evidence left under a microscope, not by what's written on a sales tag. Markets evolve, narratives get corrected, and in gemology, as in science, clarity comes not from brilliance, but from verification.